All right, pre-calculus folks, or, depending on who you are, if you're not one of my students, hi, how are you? What we're going to talk about in this video is we're going to start learning how to graph graph rational functions. Remember, a rational expression is a fractional expression. It has a variable in the denominator. As you'll see here, here's a rational expression. It has a variable in the denominator, and therefore this qualifies as a rational expression. Now we're actually going to start looking at graphs of rational functions, and the only thing that makes this this is not a rational function yet. It would be a rational function if I wrote y equals. And now we are not just talking about the expression, we're talking about plugging in any x value here would then give you a y value here. So there are an infinite number of combinations here. If I were to put a 1 in, I'd get 1 plus 2 minus 99 over 1 plus 4 is 5. And so 1 plus 2, that's 3, minus 99 is negative 96 over 5. And so if we plugged 1 in for x, we would have an xy coordinate, 1 and negative 96 over 5. And that would be somewhere down here at 1 and way down there at negative 96 over 5, which is about close to a little less than negative 19. Okay? And then if we were to plug 2 in, we'd get a different number. And plug in 3, get a different number. Plug in 0, get a different number. You get it. These are functions, right? There are, for every x value, there is one and only one y value. Okay? It's a function. So, oops, let's put that back. Sorry, I didn't mean to erase that. Let's say that we have this function here, x squared plus 2x minus 99 over x plus 4. We get y equals. We could also say f of x equals the function f of x. So f is a function of x. All right? So we have this function, and functions typically have a visual graph associated with them. And what we're going to start learning about are the features of the graphs of rational functions. This video, I'm only going to teach you how to identify 2 of the features of a rational function. I am going to show you how to identify the y-intercept. That's where the graph of this function crosses over the y-axis. And we're also going to identify the x-intercept with a parenthesis s, meaning there could be more than one x-intercept. By the way, many rational functions do not have an x-intercept at all. And therefore, I'm also going to show you how to know when there is no x-intercept at all. Okay? And sometimes there's no y-intercept, and I'll show you when to know that as well. Okay? So, how do we identify the y-intercept of a rational function? This is easy. All you do is plug 0 in for x and solve. Okay? So I want to plug a 0 in for x and just get a number. Note that whenever you put a 0 in for x, that term, any term that has an x in it, becomes 0, because 0 squared is 0. 2 times 0 is 0. So 0 plus 0 is 0 minus 99. Put a 0 in here, we get 0 plus 4 is 4. And so, what's 0 plus 0 minus 99? Negative 99. And what's 0 plus 4? It's 4. And so, that is our y-intercept. Negative 99 over 4. But the way we're going to write it is the y-intercept is a point on the coordinate plane. So we're going to write it as a point, as an x-y coordinate. What did we plug in for x? A 0, right? Well, we know that we're looking for an x comma y coordinate. Okay, so in this case, x, we plugged in 0. So we're going to put a 0 there. And it's always going to be a 0 for x when you're doing the y-intercept. And what did we get for the y value? We got negative 99 over 4. And so the y-intercept of this function is 0 and negative 99 over 4, which is somewhere. Here's 0, negative 99 over 4 is down there. It's almost at negative 25. All right? Well, that was easy. I hope finding the x-intercepts is also easy. It's not quite as easy, but it is kind of easy. To find the x-intercepts, here's what you have to understand. The x-intercepts are the x values where the whole function is equal to 0. So you have to set the function equal to 0 and solve for x. Now here's something cool. This is actually kind of easy to do, because did you know that a fraction always equals 0 as long as its numerator is equal 0? So 0 over 7, that equals 0. 0 over 73, that equals 0. 0 over 114, that equals 0. 0 over 96 equals 0. 0 over 1,462 is also equal to 0. Anytime the numerator of a fraction is equal to 0, the answer is 0. The only exception to that is we don't do 0 over 0. That's called an indeterminate form. You can wait until calculus for that. When you get to calculus, that's when you're going to learn about 0 over 0. But we're not doing that in this class, okay? All right, so we know that if the numerator equals 0, if the numerator is equal to 0, then the whole thing is equal to 0. So to find the x-intercepts, all you do is set the numerator equal to 0 and solve for x. That's all you have to do. So we're going to take the numerator here. We're going to take the numerator and we're going to set it equal to 0. So x squared plus 2x minus 99 equals 0. This is a quadratic equation now. We now have a quadratic equation. Now, if this was a linear equation, if this said 3x plus 7 equals 0, that would be easy to solve. We would just go minus 7 from both sides. 3x equals negative 7, divide by 3, and x equals negative 7 over 3. Linear functions, or linear equations, are easier to solve. Quadratic equations are a little more difficult to solve because you can have up to 2 answers. And you can't simply move everything to one side because we have x's in multiple terms. So if you remember, to solve a quadratic, this will come from college algebra, which you took, which you should know, right? That in order to solve a quadratic equation, you either have to factor and set the factors equal to 0. You can use a technique called completing the square. Completing the square would work on this if you want to, well, I mean, I know it'll work, I just don't know if I want to show you right now. But completing the square will work on this. Similarly, what else will work on this? Extracting square roots won't work on this except through completing the square. But you can use a quadratic formula on this. That'll work as well. I happen to know that factoring is going to work on this. That's what I usually try. I try factoring first, and if factoring will work, I'm happy. Otherwise, I usually go to the quadratic formula. I wouldn't mind completing the square on this, though. You could try that, okay? It'll work out. All right, so here, if we're going to factor this, we're looking for 2 numbers that multiply to negative 99, but add up to positive 2. Okay? So pause it and think about this for a minute. Try and make a little list of numbers. What 2 numbers multiply to negative 99? There's really only like a few numbers that multiply to negative 99. You got 99 and negative 1, negative 99 and positive 1, 11 and negative 9, 9 and negative 11. Well, in this case, 9 and negative 11 could be right, except that 9 plus negative 11 is negative 2. Oh, positive 11, negative 9. Positive 11 times negative 9 is negative 99. Positive 11 plus negative 9 is positive 2. We got our 2 numbers. So this is x plus 11 times x minus 9. And this is equal to 0. Now that we factored it, we set each of the factors equal to 0 and solve. See, they're linear now. Linear equations are easy to solve. X plus 11 is equal to 0. X minus 9 is equal to 0. Subtract 11 from both sides, and we get x equals negative 11. Add 9 to both sides, we get x equals 9. So we have two solutions, negative 11 and 9. As long as neither of these numbers cause the denominator to equal 0. What would make this denominator equal 0? Negative 4, right? So that's neither one of these numbers, and therefore we have our x-intercepts. We have an x-intercept at x equals negative 11, and we have an x-intercept. Oh, and remember, intercept, sorry, hang on. Well, you can write it as x equals negative 11 or x equals 9. You can also write the x-intercept as coordinates because it's a point on the graph. And it's going to go like this. You're going to write the number first, negative 11, comma, then 0. Because remember, we're trying to find where the function is equal to 0. And the function is the same thing as the y value. Here, this one would be 9, comma, 0. And we have our x-intercepts and our y-intercept. Okay? Why don't you try one now? I'll erase this. I'll erase this. And I'll give you a new problem. And then you identify the y-intercept and the x-intercept. So let's say that we have f of x is equal to, make it another easy one. In fact, I'll make it even, let's do this. X squared plus 9x plus 20 over x minus 2. Okay? All right, go ahead and pause the video and identify the y-intercept and the x-intercepts of this rational function. All right. To find the y-intercept, we just put a 0 in for x. So put a 0 here, that cancels. Plus put a 0 here, 9 times 0 is 0, plus 20. Here, 0 minus 2 is negative 2, right? So this one up here, 0 plus 20 is 20. 0 minus 2 is negative 2. So it's going to be 20 over negative 2, which becomes negative 10. And so the y-intercept is 0 and negative 10. That was easy. Now let's get the x-intercepts. All right, to find the x-intercepts, we just set the numerator equal to 0 and solve for x. So we're going to take this x squared plus 9x plus 20 equals 0. We can use the quadratic formula. We can use, might be able to factor. There are a few things that we can do to find this, but let's go ahead and factor. This will factor. Two numbers that multiply to 20 and add up to 9 are positive 4, positive 5. So this becomes x plus 4 times x plus 5 equals 0. Set each one of these equal to 0 and solve. Subtract 4 from both sides. X equals negative 4. Subtract 5 from both sides. X equals negative 5. And so our x-intercepts are negative 4 and x equals negative 5, or write them as negative 4 comma 0 and negative 5 comma 0. And that's our x-intercepts and our y-intercepts. You're going to have to do a whole bunch of these. You really got to know how to identify the x-intercept and the y-intercept. Because in the video for Thursday on graphing, we're going to graph rational equations. And what you're going to do in that video is you are actually going to plot the y-intercept and the x-intercept. And you got to make sure that you draw the graph through those points. Okay? That's all I have for you now.